This is CPM Calculus Chapter 3, number 50. What a day! So here's a graph of the distance, right? Here's the graph of the distance. So this right here is the distance axis, and here is the time. So here is the graph of the distance David traveled away from his home on a trip to the mountains. Okay, so he's going to the mountains, and here he starts. The distance is 0, and it goes all the way to how far he is from home, distance from home. Okay, place the events at the right in the proper order based on details from the graph. So trace the graph and identify the parts that correspond to each event during David's trip. Okay, so let's go over these. 1, David had to drive back to pick up his credit card that he forgot at the restaurant. So he's driving back. So wherever he's at, he's going closer to home. It sounds like, because he's backtracking. Okay. Event 2 is David's car breaks down, and he is towed back to a repair shop near his house. So this looks like he's going back by his house, and we know he starts at his house here, right? His house is the distance. Here's his house, and here we go away from the house. Okay. So this one looks like he's going back to his house area. Event 3, David stopped for gas and got a quick bite to eat. Okay, so there he's stopping for a while and he's eating. Okay, 4, David got pulled over, so he received a speeding ticket. So it seems like he's going too fast, right? Too fast, and gets a ticket. And then he continued his trip at a slower rate. Okay, so he slows down after. Okay, so let's look at what we have here, and here's our graph. So are any of these obvious to us? Well, the only one that I see right away is if his car breaks down eventually and he's towed back near his house, that means his distance has to be close to 0. And these are all above 0 except for this one. This could be like the distance here could be the repair shop. Okay, so I'm going to say his car breaks down here, right, at this time, and then he gets towed back home, so the distance from home gets less and less and less. So this event is event number 2. Okay, so we did that one. He stopped for gas and got a quick bite to eat. So when his distance is just flat, right, I'm going to guess here his distance is not increasing or decreasing. I'm going to guess here is the point where he could stop and just not have any distance growing from home, right? So I would say this is event number 3. Okay, so that one's done. So let's look at 1. 1, he had to drive back to pick up his credit card that he forgot at the restaurant. Well, he's eating in event 3, so I'm going to guess maybe he stopped at a restaurant there, but no. These are all he's going away from his house, right? The distance is growing. Here is the point where he's going closer to home, right? So this point, he's going closer to home. So I'm going to say that's where he's going backwards to pick up his credit card that he forgot at the restaurant. So this right here is going to be event number 1. Right? And finally 4, David got pulled over and received a speeding ticket. So where is he going too fast? Because eventually, so when he gets a speeding ticket, he gets pulled over here. So I could see that maybe he gets pulled over here. He stops, right? And then, so his rate, he's going pretty fast here, right? It's a constant speed here, but his distance is growing pretty quickly, and then it grows slower. So I'm going to guess this is where he's going fast, right? Zoom. And then here's where he gets pulled over, and then he slows down. Okay, so this right here is event number 4. So the order of the events is 4, 3, 1, then 2. Okay, so now that we're done, let's answer parts A through D. So A, what are the units for the slope? Well, we know the slope of the line is just going to be the change in y over the change in x. And we know the change in y is going to be miles. So just looking at the units, it's miles. And the change in x is going to be time in hours. So hours. So the slope, the units, is just going to be miles per hour. You could just keep it like this, miles per hour, or you could write miles per hour. Okay, either way. Okay, part B, what is significant about the slope when David is stopped? Okay, so we know that when he stopped, like in 3 here, he stopped, his distance is not growing, right? It's pretty flat. Also, when the police pulls him over here, it's a flat line. His distance isn't growing. So what do we notice about the slope of these lines? Well, the line distance curve is horizontal line, right? So that means the slope is equal to 0, right? Whenever you see a horizontal line here, the slope is 0. So wherever he stopped, slope equals 0. Okay, part C. Let me move this down. Part C is, how does the slope of the curve tell you when David is speeding? All right, well, we know that the slope is pretty sharp, right? It's going, the change in y over change in x is very high, right? So here, the slope is really, really high, right? If you take your, like your hand and you follow the curve here, right here, your hand is almost vertical, right? And then it slows down here, and it's less vertical here. It's more like going from the bottom left to the top right, right? So here we know when he's speeding, the slope of the curve is very steep. It's a steep slope, right? Okay, and it also, he's speeding and it goes to near 0, right? Because he gets pulled over, right? In event 4, he received the speeding ticket. Well, the policeman pulled him over. The slope is very steep, and then becomes 0. Okay? And finally, in part D, interpret the graph where the slope is negative, right? So the slope is negative. Let's go back up to the graph. Okay, we have positive slopes everywhere here, right? It's going up, 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 up. So here the slope is negative here, right? Slope is negative here. And also here we have a negative slope. Let's just write negative slope. We point an arrow to that. So what does that mean when the slope is negative? Well, he's backtracking, right? He's going back toward his home. Right? Since this is his distance from home over time, well, when he's going down, right? When the distance is decreasing, that means he's just getting closer to his home. All right, this ends CPM Chapter 3, number 50 of Calculus.